So the last step in cellular respiration is going to be the electron transport chain. And relatively speaking, this one is going to be our quote unquote money maker. Okay, this is where we are going to create the most ATP is going to be in the electron transport chain. So it is located in the cristae of the mitochondria. So this is going to be the folds. Electrons are passed through a series of electron carriers. You don't have to know that they're cytochromes. And these electrons are going to enter the system and leave the system. And when they do, they are going to, we'll see, have an influx of hydrogen ions that's then going to go create ATP. So that's basically what's all going to happen. So when we have these electrons that we get from our electron carriers, NADH and FADH2, they're going to come in the chain, pass off their electrons, and as energy is stored and transferred, we are going to create a hydrogen ion gradient. So these hydrogens are going to combine with oxygen to form water. Okay. And then NADH and FAD are going to be recycled. They're going to go back to pick up more electrons from glycolysis, prep reaction, and citric acid cycle. So again, we get NADH from glycolysis, prep reaction, citric acid cycle, and FADH2 from the citric acid cycle. And they are all going to go to the electron transport chain to make a majority of our ATP. So electron carriers are going to be located in the cristae, in the folds of the mitochondria. Our electron carriers are going to pass off our electrons. They just dump them on the electron carriers. And as they pass, they then are going to pump hydrogen ions into what's called the inner membrane space of the mitochondria. And as they pump these hydrogens, they are going to create a proton gradient. And this proton gradient is going to be really important in a second. So electron carriers dump off their electrons. As the electrons go through the chain, they shift hydrogen ions into the inner membrane space. And then we're going to have a high gradient, a high amount of these hydrogen ions, also called protons. Just know that protons and hydrogen ions are the same thing. We're also going to have a high amount of these accumulate in the inner membrane space. So these hydrogen ions are going to flow back down. Remember, what goes up must come down. It's going to flow through what's called ATP synthase. Remember, anything ends in ase is an enzyme. So those hydrogen ions that have a high concentration are going to go through this ATP synthase. And as they pass through the ATP synthase, they are going to form ATP. And this whole process of having hydrogen go down an ATP synthase to create ATP is called chemiosmosis. Osmosis is water, right? The movement of water. And we are going to have water be our final electron location at the end. So here's just a picture of our mitochondria. Again, the cristae are the folds. This is where we are going to have the prep reaction take place and the electron transport chain take place. The matrix is where our citric acid cycle is going to take place. Okay, so this might look like, holy crap, this looks really confusing. It's really not, because you don't have to know names of everything, okay? You don't have to know about coenzyme Q or cytochrome reductase. You don't need to know all that stuff, okay? Names, don't worry about it. It's the process that we're really going to be worrying about, okay? So let's just start at the beginning, which is like right here, okay? So this is our cristae of the mitochondria. This is the matrix. And then this is the inner membrane space. So right here we have our electron carrier, NADH. It is going to drop off its electrons, okay? As this electron goes through the electron carriers, hydrogen gets shifted, okay? So this electron went through, hydrogen goes through. This electron is still traveling, hydrogen's gonna go through. This electron's still traveling, hydrogen is going to go through. So we then are going to have all this hydrogen, okay, accumulate in our inner membrane space. So that's the first step. Now, we are going to have oxygen accept our electrons. So these electrons are going to come, they are going to attach to oxygen, and that's where we get our water. So I'm pretty sure a question on the test is going to be, what is the final acceptor of electrons during the electron transport chain? And that answer is oxygen. So oxygen is going to accept those electrons. When it accepts those electrons, it then turns into water. Okay, so that is the first step. Now, let's talk about all these hydrogens. So far, we haven't created any ATP yet. So we have all these hydrogens built up, okay, in our inner membrane space. So again, what goes up must come down. So they've gone up, they've gone through the cristae. So we have a high concentration. So these are going to go down the concentration gradient, high to low. We're not using any energy. This is passive transport. High to low, down the ATP synthase, okay? And as it does that, it creates ATP. So these hydrogen ions that were shifted into our inner membrane space up here are going to go back down the cristae through the ATP synthase into the matrix to create our ATP. And now our ATP can go to wherever it needs to go through an ATP channel. Okay, so that is the electron transport chain. Now, what's the energy yield? What are we talking about? So remember, we get 4 ATP through substrate level ATP synthase. This is 2 net from glycolysis because we had to use 2. Remember, we had to have that energy investment phase. And then we get 2 from the citric acid cycle. Our moneymaker of the electron transport chain creates 32 to 34, depending on how efficient it is, alone. So this is the main way that ATP gets made, is through the electron transport chain. So this is basically an overall picture. This is a really, really good photo for you to look at and study. So glycolysis, glucose creates pyruvate and 2 ATP. The prep reaction, we could say, is right here. Okay, pyruvate creating acetyl-CoA. We don't get any ATP, but we do get these electron carriers, right? So these electron carriers come from glycolysis. These come from the prep reaction. This is a citric acid cycle. Acetyl-CoA goes in. We get our carbon dioxide because we're breaking apart those carbon molecules. We get NADH and FADH2 as electron carriers. So all of these go to the electron transport chain, which is going to create our ATP. And then finally, we have oxygen. That's the final place for those electrons, is going to create water. And overall, we are going to have 36 to 38 ATP. So this is the energy yield from cell respiration, energy being ATP. The efficiency, it's really only 39% efficient. So again, according to the laws of thermodynamics, we can't take and transfer all of that energy. We are going to lose some as heat, but we do get a majority of energy out of this whole process. And this is just also a good quick snapshot of the process. We have glycolysis, the function, what gets broken down, where does it happen, end result. If you can do this from memory, you will be golden for the test. Because remember, you need to know what goes in, what comes out, where does it happen. And this is basically the main function too. So like I said, this is a fabulous picture. This one and this one are really, really great overview pictures of what exactly happens during cellular respiration.